Question 2 is asking us to solve this system of equations by using a matrix. So my first step is going to be to create that matrix. So the first row, I'm only using the numbers. So this is going to be a 2, an implied 1, -2, -1. The second row is going to be 3, -3, -1, and 5. The third row is going to be 1, -2, 3, and 6. So it's kind of always good to double check that you typed in the right numbers. Kind of like linear regression, the most common mistake, at least by me, is to enter one number incorrect. All the other ones are right, but just one number I get wrong. So always double check. Okay, so then I need to go and use the calculator. So my first step is the second matrix, edit and A. So this is going to be, again, second matrix. And you want to go all the way over to edit and then select A and press enter. You should already have a 3x4 matrix here from the previous problem. So make sure that you just enter in your data points correctly. And kind of like on the first one, my calculator only shows 3 columns at a time, so you are going to have to scroll over to see your fourth column here. But once you enter in all the data, you can quit out. So second, quit. And our second step is going to be to do the second matrix, math RREF. So after you quit, you want to do the second matrix and then go over to math and all the way down to RREF. Then press enter. So you should have RREF on the home screen. Then the third step is to go back into the matrix menu for the third and last time. And this time it's going to be, again, second matrix. It's just going to be under names and under matrix A. So if you press enter, this should appear in your home screen, RREF of A. So it's going to find the reduced row echelon form of matrix A, and this is what we get. And again, our final answer is in the final column. So this means x is equal to 1, y is equal to -1, and z is equal to 1. And again, they want us to write this as an ordered triple. So my final answer would be 1, -1, and 1. Another thing to mention here is that we're using the matrices to solve systems of 3 equations, 3 variables, but you could go back and use this to solve a system of 2 equations, 2 variables. Your dimensions, if I were to do it right here, your dimensions would have to be a 2x3 instead of a 3x4. But you could solve, let's say if you had like 2x plus 7y is equal to 99, and -x minus 6y is 102. I would not actually solve this because it's probably going to give you a weird answer, but your matrix would be 2, 7, 99, -1, -6, 102, and you could get the answers the same way. So this can be used for just the XY systems of 2 equations, 2 variables, but we primarily use it for the 3 equations, 3 variables. But it really will work for any systems of equations.